make a little introduction to this video on the end bearing support for the mill stop fixture. Just a little introduction of what the video's about. I'm over here at the bigger shop. I'm doing a little grinding operation. You might be able to see here the machine grinding these tools for a customer here in Houston. It's these tools right here. And I'm also running this horizontal mill over here in the background, so it's kind of noisy. You don't actually realize how noisy it is in the shop until you film it on video and you realize you've been listening to this noise all these years. It's very loud, but you don't even realize it because you're so used to it. But anyway, this video is going to be on, we're going to do an explanation of spindle probing cycles, the Renishaw Easy Set cycles, and as well as an explanation on how tool sets, the fixture offset can influence your tool offsets a little, and different ways to do that. So that's what this video is about, and there's going to be a little bit of machine work on the bearing support as well at the end of the video. So let's get to the video and the explanations. Here's our setup for the what we're doing with this part. You may have noticed that right here and here I milled this in my previous video, but the camera battery went dead on me and while I was milling it, and so I've actually milled it on both sides of the part. I don't know if you could see it there because I had to redo the program. So, but where we're milling, it's going to cut all of this away here. We're going to have these two holes left in there where they might intersect the bore where the bearing is. I'm not sure yet. We're going to see. We might have to plug those with something. I had to run the program again. Both sides of the part are fine, but I had to run it again because of the battery went dead on my camera in the middle of trying to film it before, and so it's not going to hurt anything. I think I'll just have to plug these 1/4-20 holes here. The rest of this is going to get all milled away for the other rest of the part here in these holes. This is all going to be cut away, you know, kind of like this, like the shape of the part. And so it's not really that big of a deal, but these two holes might end up intersecting I don't know how far the bore of the bearing, where the bearings go is, but it really won't make any difference. I'd plug them with something, and it's just a fixture. You know, this, I wouldn't have done it if it was a customer's part, but in the case of this, it's just a fixture. So that's the setup, and I'm going to show you the probing cycles. I'll do a little explanation, not a big one on the probing cycles that I'm using for this particular setup to do this part, and then we'll get into what we're going to do here. As far as we're going to actually put two tooling holes in here, like if you watched the previous video you saw in the model, and we might mill a profile around here just to put a chamfer around this part of the part, so when we flip this over and clamp it directly to the table down here without the vise, that we can mill down to that chamfer and not have to hit the table with the end mill or anything. You know, the chamfer is going to be maybe about an 1/8 inch chamfer or something like that, so we can stop in that chamfer and won't risk running into the table, you know, or marking the table with the milling cutter. In order to set this part up in the vise, we've got it clamped in the vise, and we're going to indicate the part 0 with the spindle probe. I'm just going to enter a few of these probing cycles and kind of describe what they are and what they mean. G65 is the calling of a macro program, and P9023 is the Renishaw's Easy Set probing cycles, which have to be in the memory of your machine in order to use them, and of course your machine has to be set up and functioning with the spindle probe in order to use this. But I had a few questions from some people earlier about this, and so I'm just going to enter in these probing cycles. I've been using them in quite a few of my videos, and thought I would just show what they mean here. The 9023 is the Renishaw Easy Set. Then we're going to go A8 point. We're going to probe towards us, or the table is going to be moving away from us, and that's this A8 point is the probing cycle in the Y direction here, the Y minus direction. And then we're going to go S1 is the S1 is G54, S2 would be G55, and so on. And then we're going to go MOO, end of block, put a program stop there so we can put the machine in manual and jog it to the next probing cycle, because we're doing this manually, not automatic. You can do it automatically, but the Easy Set, the Renishaw Easy Set program is to manually probe a part to set up the work offsets or something like that. Or you can even use it to do to set tools on this tool probe on this little Haas machine as well. So we're going to go another one, G65 P9023 A3 point, which is going to be an inside web measuring cycle, and we're going to go in the X direction because this key slot on this part is in the X direction. 0.625 is the size of the key. S1 end of block. Okay, so G65 9023 P9023 is the program it's calling. The actual names of the program in the controller are going to be O9023, but in this kind of cycle you call the program with a P designation. A3 point is for an inside web measuring cycle. It's going to go back and forth between the walls of the web, or the slot I should say. A web would go over the top, would be an A4 point. So an A3 point is an inside slot, I should say, actually. And the X 0.625 is the width of the slot in the X direction. S1 is for the fixture offset G54 we're setting. And then we're going to go MOO here for program stop. Then we go G65 again, P9023 A9 point, S1 end of block. That's for the A9 point is for the Z direction, down in the Z. So just to go over these numbers, A5 point is for the X direction in the plus, A6 point is X in the minus, 7 point is a Y in the plus, 8 point is Y in the minus, and 9 point is Z in the minus for the probing cycles. And the first probing cycles, which would be 1, 2, 3, 4, or A1, 2, 3, 4, are for probing features of the part. Like in this case, we're using an A3 point for an inside slot. Just across the slot measurement sets it in the center line of the slot. So now we're going to go over to the probe here, and we're going to run these cycles. I'm going to also put an MOO here just to stop things. I'm going to run these cycles in this order to set up the part zero of this part where we got in the vise. So here's the part in the vise. So we're going to, I've already indicated along here to make sure it was straight. And now we're going to set the Y first, which is going to just probe directly into this face here and set the 0 point on that edge there of the part. So let's go back to the MDI screen here. Okay, we're ready to go. This is going to probe fixture offset 1 in the Y direction, just like you saw the code I entered. Okay, then there's a program stop to stop it. So we have a chance to go over here back into the manual mode. And let's just jog it over here in between this slot, key slot here, somewhere like that. Then we're going to run the second cycle is gonna probe back and forth this way, the slot, set offset 1 again. Okay. Then we're gonna stop at the program stop here so we can jog it again. Come up here, come back here a little ways. I'm gonna set the Z0 right on the top of the part here. Okay, so that's how you use this Renishaw Easy Set programs. It's pretty easy. You just got to memorize which ones do what. In a later video, I'm going to go into more detail on how this works and how you can use this probe to automatically set offsets and adjust for the size of things and rerun the tools all automatically to get the size right to the size you want based on what the probe measures. But that's going to be for another video. Let's talk a little bit about how your fixture offsets would influence your tool offsets. And the X and Y is set wherever you need it in the program, but when you set the Z of your fixture offset, it would influence the way you might set your tool offsets. So let's look at a few little sketches here. Let's say this is the spindle of your machine. Here's a tool that's sticking out of the spindle. I'm not going to draw the tool holder. Let's just assume that that's the tool and the tool holder. And here's your piece of work here on the table or in a fixture on the machine of some sort. Now there's 3 different ways you can set your tool offsets based on where you set your fixture offset on the fixture offset page. So we'll call this number 1 method here. If you set your fixture offset with no value, in other words it's setting at the machine home position or 0 return position, this would be the fixture offset at a 0 value, and you set your tool offsets to come down to the workpiece from the tip of your tool. All the various different length tools, you just touch them off on the top of the work, and this dimension here would be your tool offset. That's the first way to do it. Then there's the second way. Let's draw another little sketch similar to that one, where here's your tool again, here's your piece of work, table, and you set your fixture offset with this dimension. You jog a reference tool down to the work, and you set this dimension here as your fixture offset, and the tool offset on the reference tool will be set to 0 here. All other tools, if they vary in length from the reference tool, would either go plus if they're longer, if this is the reference tool's length, or they'll be minus if they're shorter on the tool offset page. We'll call this number 2. Now the third way is very similar to the number 2 way. Draw the spindle again here with your tool, work down here on the table, but instead of using the reference tool, you set from the face of the spindle down to the workpiece 0 as your fixture offset, and then all of your tool offsets are going to be measured from the face of the spindle whatever length, and they'll all run in the plus direction. What the machine is doing is adding these to wherever you set the fixture offset. It's adding these numbers to bring whatever length tool down to the 0 point of the workpiece that you've set as 0. Now this would be the number 3, we'll call it. Now number 2 and number 3 are basically identical, except that you have a reference tool instead of just setting it at the face of the spindle, or this would normally be considered the gauge line of the taper in reality, but the face of the spindle works out to be pretty much the same, and you can actually just use the face of the spindle to set this. The number one method has the disadvantage that if the workpiece height changes in value, in height, let's say it's higher or lower, you have to retouch off all your tools unless you're willing to move your fixture offset up and down, but you really don't have a good way to know how much to move the fixture offset until you try to touch off one tool or something. So you end up touching off all the tools over and over again depending on the workpiece's height. This is of course assuming that you're able to use the same tools in your tool changer or whatever, and so you don't, once you touch a tool off, hopefully you wouldn't have to retouch it off or measure the length of it. But with this method you have to do it every time. With this method you don't, but you have this reference tool. Depending on what you're using for the reference tool length, some people might use like a Hamer dial indicator that can measure in the Z direction and say they're going to call that 0 wherever that indicator zeroes out. But if you broke the stylus on that or something, you would lose track of where your tool zeros are and you'd have to re-establish it. All three of these methods work, and I've used all three of these methods, but I prefer the method number 3 for a few reasons. Although it's very similar to this number 2, except that you don't have this reference tool. So you set your fixture offset one time, and then all your tools float with whatever fixture offset you have. And this also allows you to measure the tools off the machine, say if you have a tool setter or something like that. And if you have a Renishaw probe, like this little mill I have in the garage here, has this tool probe here off to the side, and it automatically will set the tools this way. So you're pretty much required, if you use the Renishaw probe, to set your fixture offset like this, which you normally do with the spindle probe. In the case of that setup, you just touch it off and it figures out this height, because the spindle probe actually has an offset for its length, and when you touch it off it adds that, and it gives you this height here from a zero return position of the machine. So this method here is kind of the preferred method and most used, although I've seen people use all three of these methods, and they still do in the shop that I rent space in. They kind of almost use this method all the time right here. Although I've been trying to get them over to this method number 3 because they bought a tool setter, and this is the best way to go. If you use a tool setter away from the machine, you could set all the offsets or print out a list of offsets, and they can input it into the control or download them to the control too also. This method number 2 is quite often used on lathes, because if you have the turret of the lathe, then you got your first turning tool in here, that you'll touch the Z offset onto this tool, and you'll use the turning tool as a reference tool for all the other tools. And so this method is actually used pretty much all the time on lathes that don't have milling capability. It's usually the way, or even the ones that have milling on the turret, but you wouldn't use this on say an Integrex, which has, like my lathe, because it acts more like a milling machine, and you would use this method here as well on the Integrex. Okay, this is the model in the CAM software, and we're just going to run the graphics here so you can see what's going to happen when it mills it on the machine over there. So first we're going to drill a hole through here, speed this up a little bit. The 2 tooling holes. I'm going to mill the counter bores, the cap screws that we're going to hold this down to the table with. I'm going to profile around the OD but leaving stock, about 20,000 stock, and then cut a chamfer on the top edge, so that when we flip it over in the on the table, clamp this side down on the table, that we don't have to mill anything beyond whatever this chamfer is right here. This is the part milled up to this point. I milled around here, leaving about 20,000 stock, so that when we flip it over, we can mill just to the end of this chamfer from the other side when the part's flipped over. I've also already flipped it over and milled these counter bores on the other side, so we can hold it with a 1/2-inch socketed cap screw down to the table without the vise or anything on there. So in this chamfer we're trying to get approximately 1/8 of an inch. It's not critical, it's just a chamfer. We're probably gonna have to plug these holes, these two holes, because I milled this on both sides because of the problem with the camera battery running down in the middle of my previous video, the shots I made. But that shouldn't matter. That's just maybe a little plug or even some epoxy or something in that hole just to plug the hole. So the bearing's going to be down here. So now the next thing to do is to take the vise off the table and clean all this mess up and get the part mounted on this face down to the table with these two screws, and then we can mill, just cut the OD off, these two chunks off of here to get rid of them, and finish the outside profile around here, and rough in these bores and bore the first side for the bearing. So that'll be the next step, and then we'll flip it over and bore the other side for the bearings. There's also a face screw we have to put in one face here for the labor seal on the fixture part that rotates, and on the other side there's 4 tapped holes, like you may have noticed in the model, that's going to just bolt the end cap over here to protect the end of the shaft and keep coolant and shavings out of there. So that's it for right now. The next setup will do the other side.